Hey there, everyone. My name is Andrew Kittredge. I am the Civic Innovation Lab Director at Beta NYC. I want to give a big thank you to the Department of City Planning for organizing this great series of hybrid events today. I've really enjoyed all of them so far, and I'm sure I'm going to enjoy this one as well. Thank you for everyone attending in person as well. Open Data Week is a week celebrating New York City's open data. It is co-organized by the New York City Open Data Program at the Office of Technology and Innovation, Beta NYC, and the Artist Collective Data Through Design. We kicked off this year's festival with the latest edition of the Data Through Design exhibition corpus at Brick on Friday of last week. New for this year, it's up for 2 weeks. So if you didn't get a chance to check it out on the opening, you still got some more time. We are ending Open Data Week this year, as we do every year, with Beta NYC's in-person School of Data conference on Saturday. If you've enjoyed any of the events this week, I'd highly recommend picking up a ticket and coming on down to the CUNY School of Law on Saturday. It's going to be a really great day. And with that, thank you again to the organizers, and I'll turn it over.
All right. Thank you, Andrew, and to the packed crowd here. Welcome to the Fast Tracker Application and Data Development presentation, where we'll be walking you through how we developed the app and the data processing behind this application. First, I'd like to introduce myself. I'm Matt Croswell, the Open Data Coordinator for City Planning and the JS Team Lead. I'll be joined by my colleagues in the JS team, Jack Rosacker and Casey Smith, and Damon McCall from Data Engineering. To just get started, we'll start off by having an overview of the policy behind Green Fast Track rule. Jack will walk us through an overview and demo of the application. Then Damon will walk us through the data processing that powers the application, and Casey will take us through lessons learned and the maintenance of the application. We'll end with a Q&A. Just to get started, so what is the Green Fast Track rule? The Green Fast Track was created because New York City is going through an affordable housing crisis. And to deal with that affordable housing crisis, the city released a Get Stuff Built report, which also created the Building and Land Use Application Streamlining Task Force. These are all initiatives with the primary objective for alleviating the housing crisis. And to do that, one of the main primary objectives was to eliminate red tape and procedural obstacles in the housing approval process. And so one of the ways to do that was to look at the factors that are adding to the length and cost of creating housing. And our city planning studied 1,100 different housing, simple and modest housing projects, and analyzed their environmental review and determined that those type of projects, if they meet a certain criteria, do not have an environmental impact. And so to streamline this system, the rule is there to basically make the projects eligible for a streamlined environmental review, known as Type 2. In order to be eligible for Type 2, the projects must meet certain criteria. The first part of that criteria is based on zoning and bulk, so the size of that project. And the other criteria is the proximity to many different environmental variables, like air quality, noise, or hazmat. The Green Fast Track rule has the goal of eliminating the time and cost in the approval process. And the goal is to create cheaper housing, quicker review process, and to create opportunity to create more housing. So our policymakers came to us and said, now that we have this rule passed, we need an application that allows applicants to determine their eligibility for the rule. And they came to us with these a few requirements. And so one of the requirements is to centralize all the authoritative data into one location or one application, to visualize the proximity of your project to the environmental variables, to be able to enter that project data and determine your eligibility, and to communicate project eligibility. The applicants can get an automated report that lets them know whether the project is eligible or not. And then the last requirement is to standardize the report submission package so that the applicants can submit that to this seeker lead agency. I'm going to turn it over to Jack to run us through a demo and overview of the application. He was the tech lead and head designer and developer of this application. Thanks, Jack.
All right. Is it possible to get on this screen as well? Just 1 second here. It is. Great. Okay. Thank you. All right. Hello, everybody. I'm Jack Rosacker. I'm on the GIS team here at City Planning, and I'm going to talk through, give a quick demo of the application, and then we're going to talk through the different components that went into building the app. So, like Matt was just saying, kind of the primary incentive for building this product was to have a self-service interface that would allow users, applicants to access all of the data they needed to determine whether their housing project was eligible under this new green fast track for housing rule. Self-service part's really important, and the ability to self-calculate eligibility was really important. So I'm actually going to jump out of this presentation here, and we're going to go to the app itself. All right, so as a user, I land on this page, and the first thing that I'm supposed to do is to select the tax lots that are relevant to my proposed housing project. I'm instructed to do this via the text at the bottom, and then also this tool guide sidebar that pops up and illustrates the various action steps here. So I'm going to zoom into a hypothetical development location. So as I zoom in, you can see these tax lots populating. I can get there via this search bar at the top, search by BBL or address, or I can just go here manually. Once I'm in my location, I'm going to use the selection widget or the selection tool here. I'm going to grab the lots that are relevant, and these can be relevant either because they are the site of proposed construction or because they're associated with any associated rezonings. So I have my selection, I have the count here, I've got 7 lots selected, and I'm going to begin my survey. So this is the kind of the primary, where most of the work happens in the app. So as a user, you can see my lot selection carried over. I can zoom out, you can see various data sets populating across the map. Below the map, we have a data table, and the data table shows tabular data relevant to each selected tax lot. And then the columns are filtered and reflect the section tabs up here. And these section tabs control which map is presented and refer to sections within the survey, which is to the right of the screen here. So the primary workflow for an applicant or a user of this app is to work their way down through this survey on the right and to populate the questions based on information that's either contained within the map, the data table, or non-spatial information that's relevant to their project. So we're not going to go through each of these questions, but I wanted to show, let's see, so this survey is broken up, like I said, into various sections. These are kind of natural breaks within the subject matter. But then also, we just have like a tremendous amount of data by between 40 and 50 different data sets that we needed to represent in different ways. And so this allowed us to kind of present those more clearly to the user. Yeah, so as a user, I'll be going through, I'll be filling out this survey. As I'm filling it out, I will be getting immediate kind of preliminary eligibility feedback based on the information that I'm entering. So for example, you can see here it's asking, will my proposed development burn fossil fuels for any heating, cooling, or hot water? So according to the rule, if I answer yes, I'm going to get this immediate response. You saw that text populate that says that this project is likely not eligible under based on this information. If I say no, then that's fine. I can continue and answer the rest of the questions. If I say unsure at this time, then additional dynamic text will populate that's saying, this is really important, and your reviewing agency will need to know this information before eligibility can be fully determined. There is also dynamic behavior that only shows certain questions based on the answers to previous questions. So if I say that my proposed buildings will be over a certain height, then it's going to ask me follow-up questions about will those buildings cast shadows on sensitive sites? So we're going to work our way down here, kind of fast forwarding through this user experience. So we can see each of these maps contains a bunch of data relevant to the Green Fast Track for Housing rule. As I get to the bottom of the survey, it's going to prompt me as the user to produce two kind of tangible outputs. The first output is a CSV or a table. And then these are all of the tabular attributes that we saw filtered in those previous map views. So I can export this up here as a CSV. That's going to download to my local machine, and then I can share that with my lead agency when I'm ready to submit my package. The second piece, the second kind of tangible output is when I click the submit button at the end. The back-end automation that runs behind the application will take all of the survey results, process that into a PDF report, and then send that to the email address provided by the user. We're not going to do that because I haven't answered all of these questions, but we'll talk about how that works. Okay, so I'm going to jump back in here. This is a flow chart that kind of talks about a little bit of infrastructure, a little bit of process behind the construction and behind the scenes functionality of the app. So going from left to right, we can see we're pulling in all of these different data sources that are coming from city, state, federal, port authority, kind of bridging these different administrative levels. The data is ingested, cleaned, processed by the data engineering team here at City Planning, who presented a couple excellent presentations earlier. And Damon will be jumping back in to talk about this section here. Data engineering will then host their pre-processed data on DigitalOcean, the cloud storage provider. And that's where our team, the GIS team, will pick up that data, publish it to ArcGIS Online as REST feature services. Additionally, we have used Survey 123 to create that user-facing survey with those the kind of dynamic conditional responsiveness to user input. That also gets published to ArcGIS Online as a feature service. Then over here in the Fast Tracker application box, we can see that the app itself is built using ArcGIS Experience Builder with an embedded Survey 123 widget, which we pointed to earlier. And then the last step of the process, and we're going to dive into each of these in a little bit more detail next, is Power Automate, which is the automation platform we used to enable the app to generate that PDF and then mail it to or email it to the user. So first, I'm going to talk at a high level about Survey 123. So Survey 123 is, again, it's an ESRI product that allows a user to build these dynamic surveys. We took this flow chart here is showing that we, being the technology teams at City Planning, worked with our policy partners, some of whom are here in the audience. Thanks for joining us. To process this rule language into the survey, and then that survey was embedded into the application. And you can see this kind of circular, kind of iterative relationship where we had, rule language that was still being worked out, survey, we would test it, we had to kind of iterate and make changes as we went. On the right-hand side, you can see Survey 123 Connect, which is the desktop software we used to preview and test the survey. And at the bottom, this is an interesting thing. Survey 123 Connect uses an Excel-based template to store all of the logic. So when I talked about that conditional behavior, the text that appears based on a response or questions that are hidden until something is answered, that's all contained within this logic within an Excel template. Then I'm going to jump into the components of the app here. So this is a quick overview of ArcGIS Experience Builder. So this is a low, no-code app development platform from ESRI as well. So there's a lot here. I chose one screenshot trying to kind of demonstrate what this looks like a little bit. So you can see the app in the background, or a draft of the app. On the left-hand side, we have all of these configuration options that what's displayed right now is showing the different data sources that are involved. So we can point it to a web map. We can pull in different data sources that are then tied into the various tools and widgets within the app itself. Within the app, you can see that the data table widget or tool is selected. And then these configuration panels on the right-hand side are related to that selected tool. So in this instance, we can see that we've pointed the data table at a specific data set. We've filtered it based on some simple queries, and we've limited the columns based on what data is being presented in the map. And that survey is on the right-hand side. Lastly, I'm going to talk about Power Automate. So Power Automate, again, automates that functionality of submitting the survey, converting it into a PDF, and sending it to the user. Survey 123 does natively have the ability to transform survey results into a PDF, but that's not exposed to the end user. That's something that only we could do out of the box as the data administrators. So Power Automate was the platform that we chose to stitch these different pieces of the app together to make it so that the user could generate this information without any input from us on the back end. So this is another low, no-code platform. This one's from Microsoft. So in this screenshot, a lot of these are rolled up, so there's more information in each of these blocks. But basically, each of these colorful rectangles contains logic, contains authentication tokens to third-party services. And so the first one connects to ArcGIS Online. It's a webhook that's listening for changes to that survey feature service. So when a user hits the submit button, this webhook is triggered, or rather this webhook detects that change and then triggers the rest of the automation. So going down the row here, webhook is triggered, some intermediate steps. A report is generated from the relevant record in the survey. That report is saved as a PDF to an intermediate SharePoint location. And then that PDF is emailed to the email address provided by the user in the survey. And then we'll jump to the second half of this. We have these three additional code blocks. So the left-hand side is just some cleanup. The automation creates some kind of byproducts on the way, and those need to be cleaned up. And then on the right-hand side, this is error handling. So if any failures happen in the automation, if the report can't be generated, if the email can't be sent, if a credential has expired, this logic block will be triggered, and that'll notify our team and the end user that something has gone wrong, so we don't have silent failures, ideally. That's about the end of my section. I just wanted to talk really quickly about why we chose those platforms. City Planning has a really talented full stack development team, but for this specific project, due to just some of the details of the timeline for development, some of the information we wanted to include, we decided to go with these commercially off-the-shelf kind of COTS applications. And with all of them, they have kind of upsides and downsides that Casey's going to get into a little bit more later, but they have kind of this, for me anyway, a steep initial learning curve, and then you can do a ton with them, but then you definitely hit a ceiling where if we were writing full custom code, we would be able to version the code fully. We'd be able to tie different pieces together that are not maybe available out of the box as much as possible, or as much as we would like. So with that, I'm going to hand it off to Damon to talk through data processing.
Thank you, Jack. And like Jack said, there were about 50 data sets going into this and a lot of urgency to get this up and running. So this was a very fun and satisfying project for the data engineering team that I'm a member of. And it was great for once to build a brand new data set and not just maintain ones that exist, as fun as that is. So I'm going to cover three things. What data does this application actually need? What source data is needed? And how do we transform that data? So first about what the app needs, and it's really two types of data. For every lot in New York City, we needed to determine the eligibility for the spatial criteria of this green fast track eligibility that Jack and Matt spoke through. But also, as you saw with those visuals in the application, we actually also have to hand over the source data for those results, the source data that those calculations are based on, especially to build trust, I think, when somebody's in the application looking at results, to see the source data that gave them those results in the same place is very powerful. So two distinct types of data were needed. First, the eligibility for spatial criteria. And I'll add that a big reason why we did this, why we calculated this before it gets to the application, is that it would have been very difficult, if not too expensive, literally too expensive dollar amount, to do these calculations in the application. So one of the big cons of using commercial off-the-shelf software in this case is that it would have actually cost money to do these calculations for each use of the application. So we pre-calculate for every lot the answers to spatial criteria. So you're seeing a snapshot here of specific tax lots and the answers to the relevant questions that would be in the survey. For example, is this lot not an industrial lot? Is it near an arterial highway? Yes or no? Thankfully, the answers could be binary for a lot of these cases. And so the spatial source data, which looks amazing in the application, also had to be provided. So every resource and proximity to them, and I'll get into what proximity means in a bit, but air quality sources, noise, hazmat, the list goes on, and we eventually were able to use this source data and pass it along in a way that the application could use. So that screenshot is supposed to be scary, because it was. Choosing source data wasn't easy, and maybe everyone involved is in this room using Excel for its strengths of collaboration, and using a table like this to figure out, okay, these are all the potential source data sets. Why would we want to use this one? Where would we find this one? And so using Excel first, which has kind of become a pattern of ours, to just figure out in a tabular way what we want to do. And so reviewing, I'd say reviewed more than 50, maybe we just ended up with 50, for their availability, multiple sources for the same data, how complete is it redundant, what's the format, things like that. And of course, there were challenges matching data to the legal questions, because if the legal language just says natural resource, what does that mean? And how can we be as complete as possible? The quality of the data, and data not even existing in the first place in some cases. And so to go from Excel sheet where we're discussing and deciding to, let's say, a CSV where we're trying to declare what source data we're using and describe it in ways that's useful for a data pipeline is what we ended up with. So declaring why it's needed, and by why I mean what spatial criteria is this data related to. each survey question has source data, and a lot of source data was used in more than one survey question. So it wasn't as simple as one-to-one like we thought it might be or hoped it would be. And so a table like this helped us declare that complexity in a way that we could use it in our code, in the actual SQL code. And so how do we get data? We had to talk about that earlier, so I won't get into all the technical details. But in general, as usual, we're pulling data from New York City and state open data, federal websites, and ArcGIS feature servers. The screenshot on the left is some of the source data that we use, and it's just files stored in cloud file storage, S3 on DigitalOcean. And on the right is the list of, portion of the list of source data sets that we use in Green Fast Track. So we use a text file, the format is YAML, to declare what source data sets do we need to build this data set. And with just that file, we can load that data into a database and then do what we need to it. So transforming data. Before we write any code, we had to think about what is supposed to happen in this build at all. So translating survey language to data and code, and survey language also legal language. And these are abbreviated versions of it, but language like, is the project, the construction project, within an area of archaeological sensitivity? How does that automatically get transferred to code? Who knows? Is the project substantially contiguous to a resource, to the proximity problem? So we started with language like this, ended up with code. In general, though, when we're transforming code, on at least for us, we're using SQL queries. Thankfully, because we had a blank slate, we could use dbt, which is a Python package, and it's our favorite way to structure and execute SQL code. And we use GitHub Actions to run that code. And so you're seeing in the bottom left, sorry I'm showing any code at all, but some people are into that, a SQL query that is an example of how we're using geospatial queries to narrow down a resource and buffer it to try and figure out proximity to it. So you could take the perspective of a single tax lot and say, how close am I to an arterial highway? Am I within 300 feet of any arterial highways? Our approach was to buffer all of those resources, and if a tax lot intersects with it, then you are within 300 feet or something like that. And that screenshot on the right is just an example of how Green Fast Track, which I'll hover over a little bit with the mouse, is run alongside all of our other data sets every night to make sure it's still working, and then we fix it when it's not. And so another side of transforming data, still about transforming survey language, was about zoning categories. So what is the Green Fast Track zoning category of each lot? Feels like a simple question, but tax lots may have more than one zoning district. And so the screenshot on the left, again, is from Excel, where we were just using that for humans to make decisions, where a single lot might have one zoning district, or 3, or 4, and asking people, what do you think the answer should be for this lot, experts, not us, and getting an answer like, oh, this lot should be commercial and manufacturing, and starting with answers like that to eventually come to something like this, which is a decision tree, where we can make a determination for every single lot and validate with the experts, oh yeah, that seems right. That's how we can go from expertise to code. And so using code to travel down these decisions to say, if any of the zoning districts are other, the lot is other, and we don't have to worry about anything else. But getting an answer for every lot was required. And so just to cover a few of the innovations for us with this process, again, using dbt to build a data product, something we'd like to do for all of our data products, was very satisfying. And what I didn't mention was that maybe the biggest value of using dbt is that it lets us test data as we're building it. There are many ways to test data. You could just look at the CSV and say, it looks good to me. You could write code that tests it, but thankfully with dbt, we can very easily test data as we're building. New data source type. Before this data product came to us and we had to build it, we weren't pulling data directly from ArcGIS feature servers. Now we easily can. And shout out Finn for going the extra mile to optimize some of these spatial queries using hexagons. So when you're asking, does this lot is it near a natural resource? Sometimes that polygon is the size of New York City in this case. And if you're running a query for every single lot, looking for an intersection with that, sometimes the built-in optimizations aren't enough. So Finn went the extra mile to really get us going with using hexagons to optimize things so that the build only takes on the order of 10, 20 minutes instead of probably be 4 or 5 hours. So I think that's it for data processing. If you can't tell, this was a lot of fun and very satisfying. And I'll hand it to Casey.
Hey everyone, just going to wrap up with some lessons learned and a little bit about maintenance and support before we move to Q&A, if there are any questions. So as these guys have mentioned, we were working within a tight development framework, and because the application launch was tied to policy implementation. I just want to highlight this because it was really important in our strategic decision-making throughout the development process. We were lucky enough to work with the planning support team, who, as Jack mentioned, is in the audience today. Thanks again for coming. And we worked with them on some very interesting problems, including, like Damon mentioned, translating legalese and policy descriptions into yes, no, machine-readable logic, like substantially contiguous, for example. Additionally, our data and policy experts undertook a lengthy review process, deduplicating data that came from multiple federal, state, city levels and kind of distilling it down into the composite that was relevant to this project. Lastly, one of the key takeaways I think that is important for this project is that we were all just really excited to work on an end-to-end development process, turning that policy language into an application that can provide users with clear information that they need to move through the project pipeline efficiently. So moving on to our COTS application and why we went with COTS, which again, commercial off-the-shelf software, rather than building our application in-house from scratch. For us, going with COTS was really important, again, because of that development timeframe being rather tight. And we also wanted to maintain the app long-term without kind of needing that custom code-based maintenance approach. So with that also came some limitations, which I'd like to get into a little bit, just so if you'd like to take a similar direction, you know what you're necessarily getting yourself into. So first, as Jack kind of highlighted in his demo, that inability to tie the map data directly to the survey. So ultimately, the result of that is we kind of have to rely on our user as a sort of pipeline to take that tabular data and move it from the left-hand side of their screen into the survey on the right-hand side of their screen in the form of a survey response. Ideally, we would like it to be able to be connected, but that's okay. It works. And there's also no real development environment within the ArcGIS Online platform. We were able to implement some kind of pseudo development workarounds, but that's something to note. We also encountered some limitations with out-of-the-box widgets. One that comes to mind is that the CSV export is a little bit clumsy. It requires quite a few clicks, and I think it ultimately impacts user experience to some degree, but it's out of the box, so that is what it is. We also faced a limited ability to customize our URL. Experience Builder on ArcGIS Online does not allow for custom URLs. I do believe that Experience Builder within the Enterprise framework does allow for URL customization for those of you who are building within Enterprise. But because of this, we collaborated with our IT team as well as OTI to implement just an ad hoc URL redirect. We also had to confront some shared limitations with shared privileges. The Excel file, which serves as the template for the survey, exists under a single Microsoft user profile. And then within Power Automate credentials, our team does have shared overall ownership of the automation, but the connectors to third party are not able to be shared in any kind of real meaningful way, which are just kind of two important things to keep in mind for team member transition purposes. Now I'm going to get into maintenance and support. And first, I want to start off by talking about our approach to versioning. Fast Tracker has a very iterative user base, and while it's not possible to version the COTS application itself, we do use GitHub for issue tracking and improvement planning, as well as kind of as an aside, image hosting for some of the application icons. We also developed a versioning system for the data and the application that are kind of distinct from one another. The data version was developed after the launch of the app, as we were starting to plan for the secondary data updates. And we decided to pin that version for the Fast Tracker tax lot dataset to Pluto's versioning system, just to avoid another versioning system, which we have so many of. And lastly, our app versioning is tracked in the changelog, which is also available on the product GitHub, just to ensure that any user interface updates are made available to users. Again, it's important for our iterative user base who may return to an updated app and or data since the last time they visited Fast Tracker. Fast Tracker also expiring tokens within Power Automate was also something that we encountered. The issue, if I can describe it, essentially was within the automation, there are these connectors, and they reach out to systems like Outlook, SharePoint, Survey123 in this case, as well as ArcGIS Online. And those connectors store credentials. We found that shortly after launch, one of those connectors was going stale, and that was ultimately causing some errors for our users. And then also after the app had gone live, we addressed that initial stale connector, but we wanted to find out a long-term solution for it. And so after the app went live, Power Automate released a specific ArcGIS Online connector, which we were able to migrate our webhooks to, instead of a Survey123 connector that we were previously using. And this new connector, while it still kind of presented those expiration limitations, it did allow for us to implement a basic automation that could grab some information that would reset that 14-day timer to 0 and ultimately prevent our users from encountering some errors. And it was twofold. In addition to preventing users from encountering those errors, it also notifies our team daily via email with error success statuses, which is really helpful to just keep tabs on the application. Another significant maintenance undertaking was our decision to transition from ArcGIS Online services to views. We undertook this immediately after launch. We went right back to the development process. So an ArcGIS Online view is similar to that of like a traditional database. In this case, it's not really functioning as a filter, but rather as kind of a protective shield for the source data itself. And the reason for this is the problem is that when applications are sourced directly to feature services, and maybe that feature service gets corrupted on update, which is not an infrequent problem, the app can't be repointed at a new service that is uncorrupted without a lot of manual reconfiguration, which was a significant undertaking, especially if you multiply it by the number of data sets that are in the application. So the solution was to move to views, which can easily be repointed at any source service. And so if that underlying source service is corrupted, it can just be redirected quickly without any of that manual reconfiguration within the ESRI user interface. We also, when we were kind of undertaking this secondary development process, took the opportunity to standardize our naming conventions, as well as how our feature layers were nested and grouped within their parent feature services, just to keep everything really orderly. And lastly, I'll also take this opportunity to plug a crucial, albeit potentially dangerous, ArcGIS assistant tool, which is a non-ESRI supported tool, but it was built and is used actively by ESRI staff. So for context, every service map application in ArcGIS Online has a JSON that encodes things like symbology and access types, among many other things. And ArcGIS Assistant allows you to directly interact with that JSON and update it without going through, again, that ESRI user interface. So our team was able to pull those JSONs down and migrate from the existing services towards those views without having to make, just really tinker within the application itself. And it made the process a lot more efficient for those 40-some data sets. I do want to recommend exercising caution because it can be error prone if you're not doing it without proper versioning. So just be mindful of that. And lastly, we do plan to publish Fast Tracker's data to NYC Open Data, but in the meantime, we do have some links that will be made available with the slides. If we can, we'll make it available in the Q&A, but I'm not sure if we're going to be able to do that. And these resources, you can find the data, a little bit more about Green Fast Track for housing opportunity policy, as well as its impact, and the Fast Tracker app itself. So we'll drop these links with the slides. And I think that just about calls it. So thank you, everyone, and we'll open up for Q&A. Are there any questions in the audience? Do we have that mic still?
I feel like I heard you all say that you developed this really fast, but I'm curious, how long did it take from, being asked to do this to it being out?
Do you want to take it?
Sure. Yeah, so I know the rule was worked on for a long time. Our team was involved, I think we had about 6 months from when we were approached to build a tool to when the rule was released last June, so June of 2024. That was kind of all of the different steps of are these the right technologies to use? What data sets are relevant? How do we engineer the data to work in the app? How do we re-engineer the data to work because the app works, whatever, differently than we thought? Just that whole process. So about 6 months. Yeah.
I'm curious about the process of translating the policy language into specific spatial relationships, and specifically I'm wondering if you had to deal with the problems of vector boundaries, and if you moved into having to deal with fuzziness at all, or considered moving into the sort of raster world or anything.
We do not live in the raster world, as fun as that might be. So I don't think, I'll just work backwards. I don't think fuzziness was ever really an issue because, just again, starting with always vectors, there wasn't really much to dispute. But something that's reminding me of that is the question of, are you near an arterial highway? If our source data is line data, that doesn't really tell you anything about the width of that arterial highway. So I'm not saying we solved those problems, but that is related to the fuzziness issue, where we had to decide on a buffer around these lines, these two-dimensional lines, that we felt was a responsible distance to account for the width of an arterial highway, which varies. So your first question, though, was about the boundaries generally of
Yeah, just kind of curious generally about, what it was like in terms of working in a team, making those decisions.
Oh, those boundaries.
Yeah.
Yeah. Okay. Personal boundaries.
Both boundaries.
Yeah. So I think it really started with, what do we have to do? That's what a lot of these projects start with. And so we know a rule is going to be put in place on a certain date. And so we need zoning applicants, to be able to abide by that rule and take advantage of it. This was kind of different. It was more on the side of incentivizing people to do something than there's a new rule, you're not allowed to do something anymore. So this, I think, was first about deciding, okay, what are we going to provide applicants? Okay, an application. And then just asking the people that make applications, could we do this quickly? Maybe not. So the decision about, okay, do we have people capable of doing something off the shelf? Yes. What type of data? So I think part of it was maybe minimizing the boundaries between teams by meeting frequently. And sometimes you had nothing to contribute in that meeting, but at least you were on the same page about like what was coming next. So that certainly doesn't cover it all, but that comes to mind.
Yeah, I was just gonna add, when it gets to like the legalese part of it, so the substantially contiguous, we really relied on our policy partners for that. So they worked heavily with our counsel's office and our EARD team, environmental review team, to figure out what was needed. So what does substantially contiguous or those type of vague proximity terms into actual distances that we could put into code, for the application. Well, I want to, okay, yeah.
Do you feel like using off-the-shelf code is now what you guys will be using more regularly, or to like build applications faster, or do you guys want to kind of say like that had its limitations, can't really do everything we wanted to, it's good for like, you know, a fast application that maybe is very, very niche, but isn't really like scalable?
I think it really depends on what the project is, what the solution we're trying to provide is. So depending on like the timeline we're given and what actual like functionalities needs to be delivered, that would determine what we use. Our shop, the GIS team, we're primarily an ESRI shop, and so we're traditionally using more of the COTS applications, but we'd also, as Jack mentioned before, we do have an application engineering team. There's a full stack open source developers. And so applications on our website like Zola or Population Fact Finder, those are applications that that team maintains, and they're all built with custom open source code and technology. All right. Cool. Well, thank you everyone for coming. I don't know if we have, some of you might have been here since noon, so we really do appreciate the marathon you've been through. And yeah, thank you for participating.